lesson today, and we're going to do part of it tomorrow. Okay? So, we are going to start with part A, which is factoring. So, what I want us to do is you're telling me what this factors to. Okay? So, number one, I want you to try it. I'll give you just a brief moment to try to get some numbers down, and then we're going to talk about it really quick. And I'll even put the hint up that it does start like this. So give me two numbers. What multiplies to negative 30, but adds up to positive 7? 10 and 3. Which one's positive, which one's negative? All right. So folks, the factoring piece, I'm not going to give you that much time anymore because we got to be good at it. We've been doing it for a while, so we're not spending our time factoring, we're spending our time solving. So the solving then, what does x equal? What are my two solutions? 3 and negative 10. So this is just like yesterday. The only addition is instead of giving you factored form, we are now giving you standard form, right? So I went standard form, I changed it to factored form, and then I got my two solutions. I wouldn't actually expect that work there again, but you can show it if you need to. Now, the other thing I'm going to throw out there is all these methods that we're doing today are based off standard form. If the problem is in standard form, then I need to look, what are my options? And I really have 4. I can factor it, which is honestly probably the easiest way to get solutions. I mean, look at the work that we did. There's really not a whole lot. I could do the square root method, which I would say is about the same. If I can do the square root method, the Shrek method, I'm pretty happy. Or we got the quadratic formula, which is kind of a beast, so that takes a lot of time. That's why it's further down the list. And then completing the square is just hit or miss. Some of you like it, some of you hate it. So it's kind of off towards the end. But those are the 4 options when you're in standard form. How do I solve this problem? Now number 2. I'd have 0 equals this lovely piece, and I'm going to factor it again. I only have 2 terms. I can't factor it like a trinomial. I can only look at taking out what they both have in common. What do they both have in common? 7. X. 7 and x. Okay? So I'm going to have 7x. And then inside my parentheses, I'm going to have 2x. And I'm going to have minus 3. So I factored my greatest common factor out. Now, once we get to that, this one I do expect to see some work because the leading coefficient of x there is 2, it's not just 1. So for that piece, I would expect to see 2x minus 3 equals 0, and then we solve. So plus 3 to both sides. And then I just divide by 2. So that's not too crazy there. That's one of my solutions. Who can tell me my other solution? Yeah, 0. And so I don't need to see that one, but if you want to show it, you can go 7x equals 0, divide both of them by 7, and get x equals 0. So there's my 2 solutions. So slight difference in how we dealt with the problem. We factored in the first one and got our x-intercepts. We are factoring a trinomial. Here we are factoring a binomial, which just means we have 2 terms. And we took our greatest common factor out. Slight differences, nothing too crazy. Number 3. Do I have a common difference between 1, 10, and 25? Yeah, I do. It's just 1, right? So that doesn't help us. So I'm going to go and try to factor this like a trinomial. So you go ahead and you factor it. easy. It's a 5. It will be alright. They do. Just saving lives over here. Actually, not to detour so much here, but my dog will actually like kill flies. She like just hunts them down. She like sees them and just watches them until they're her level, and then will jump up and then they fall over. So she got them. But can you imagine how none of this is going to make any sense if you're watching this video? All right. Anyway, what numbers do we get? 5 and 5 and 5. So I'm going to go plus 5, plus 5. So what's my solution? Yeah, -5. Now, we have two solutions because it's the same solution twice, right? But there's one other thing that I want to point out. What's your vertex? I'll take the 0 that I heard. Your vertex would just be that. Okay. Now, I don't need you to write that down. I just want you kind of thinking about these, kind of making some connections. So our solution is just -5. Last one. There's actually two options of doing this. We're not going to take a ton of time on it because we've done this before. Did anyone successfully factor that? What'd you get? Perfect. I'm just waiting for someone on the other side of the room to knock back, but they haven't done it yet. So this does factor to x plus 3 and x minus 3. And it factors to that because our middle term is just 0x. So what multiplies to -9 but adds up to 0, positive and -3. So that's really good. And if you see the difference of perfect squares, you should factor it like that. Like that's awesome. So my solution is going to be x equals 3 or x equals -3. That's option 1. That's actually the option that I prefer. I like that because perfect squares show up all the time. The other option would be this. I can add 9 to the other side here. How do I get rid of a square? Square root. What happens when you take the square root of 9? What do you get? No. What's the square root of 3? We're going to take both of those and stitch that together. We get a plus or minus 3 from that. Same thing, right? So anytime you take that square root, plus or minus. So either way works. What questions do we have about the factor? Your bottom page then. Bottom of that page. We're not going to do 7. So I'm going to go through this one. It's going to be very similar to the one we actually just looked at. Notice that these are in standard form, but they are missing bx. They're missing that middle term. There's no x there. There's an x squared and there's a constant, but there's no x. So when you have that, this is actually a version of the Schreck method. So what I like to do is just put 0 equals that x squared minus 10. So I'm going to move the 10 over just like I did in the last problem. Whoa, that was really ugly. And so we take a square root here. I'm going to throw my plus or minus there so I don't forget it as I'm going. Let's talk about 10. What numbers multiply to make 10? 2 and 5. Do I get any buddies from that? 2 and 5? No. Do I get any perfect squares in there? 2 and 5? No. So actually my answer is plus or minus the square root of 10, which equals x. Now, for those of you itching to get that calculator and start typing, gotta call them that, because I don't care what the decimal is, and even if you write the decimal down, you're gonna get it wrong. Because you're not giving me the exact answer, you're giving me some approximation that your calculator gave you. So I expect to see a lot of answers like this. Okay? I do not expect to see a lot of decimals. Now if it's 1.5, okay, that's fine. But if it's 1 2/3, okay? So exact answers. That's what we want to see. Any questions on 5? You do number 6 then. Again, when you're solving, you always make the f of x 0. Most of us are pretty good until we get to there. Okay? And that's good. We should be around there. I take the square root, what happens? You gotta do an imaginary. Yeah. So this is gonna be plus or minus I square roots of 5, which is equal to x. And so that is the answer. What questions do we have? All right, you know quadratic formula? We're skipping it today. Moving on. Instead, we're going to complete the square. This goes all the way back to 3-1. All the way back, many moons ago, back to 3-1. We're going to knock 13 out. I'm going to put a line down, and we're going to do 12 and 14. Now we still have the same first step. My same first step is going to be just writing this with 0. The difference here, though, pause if you're writing, I'm now going to put plus, and instead of that box, I'm just going to put a line. And, you know, when I've done this before, I actually had another box on the other side. I'm not going to do that. I'm going to show you a slightly different way. That's going to be subtracting away my other box, and then I'm going to minus 10. So I did not move anything. Okay, I'm changing our approach a little bit. And if you like the old approach, that's fine. Do the old approach. If you like the new approach, do the new approach. I'm just showing you different things. So we still utilize b divided by 2 squared. So what is that? 4. Yeah. So I'm going to put 4 in. Now, in the old version, we would add 4 to one side, and we would add 4 to the other side of the equal sign. So they were equal, right? If I add 4 pounds to each side of a scale, the scale stays the same. I've done nothing to change it. This time, if I add 4 and I subtract 4, what's 4 minus 4? 0. So if I add 0, does that change the problem? No. So it's the same exact thing. It's just a slightly different way of looking at it. Now, I like to imagine that there's a little bar cutting those off. Okay? So I factor this, and I get 0 is equal to, this would be x plus 2 times x plus 2, which, to write that more efficiently, I'm going to write that as x plus 2 squared. I still have on the other side of my bar, I have negative 4 and negative 10, which just adds up to negative 14. You know who's standing right outside the door right now? A big green ogre, because we're about to do the Shrek method. Yeah, I know. Enough said on that. So before we start the Shrek method, let's pause. Do we have any questions about the completing the square? Okay. So you tell me, what's my first step? You did this yesterday. Plus 14. Or add 14. What is my next step? Square root. Do I get an I here? No, because it's not negative. So that's actually something I do see is people are like, hey, we're in the imaginary unit. Everything I do has to have an I. No, pump the brakes on that. Got to be negative. So, okay, so we got this. So plus or minus. Square root of 14. Give me the two numbers that multiply 14. 7 and 2. Do we got any other options? No. Do I know the square root of 7? Do I know the square root of 2? No. So then I leave it. So my last step is just minus 2, and I get negative 2 plus or minus the square root of 14, and that is equal to x. Doesn't that look lovely? Yeah, it's kind of a nasty solution, but it's nice. Again, I don't want you to figure out what the approximation for the square root of 14 is. I want you to leave it as an exact answer, and it's done. Okay. If I did want an approximation, then you would have to plug it in your calculator. You would go negative 2 plus whatever it is, negative 2 minus whatever it is. Okay? What questions do we have? Does anyone need a little bit more time to write this down? All right, 14. Which method do you like better? Old method or new method? New method. All right, we're going to stick with the new. So I start replacing this with 0. I write my first term. This is actually my ax term, ax squared. I write my bx term, and then I put my two lines. So I'm going to add 0 here. So I'm going to put plus some number and minus some number, and then plus 86. What number goes in that underlined portion? Yeah, 81. 81's perfect. So I take 18, cut it in half, and then I square it, and I get 81. Oh, not 18. And I'll put my little bar there, reminding me that I'm factoring. and I'm combining the like terms on the other side. So this is going to be 0 is equal to, what's this factor to? It's x minus 9. Yeah, so I'm going to have x minus 9. So negative 9 times negative 9 is positive 81. Negative 9 plus negative 9 is negative 18x. And then over here, I just get plus 5. Go ahead, solve it. What do I get on the left side over here when I take that square root? What do we get? We get an I. Anything else? I do have to do that. What else do I need to do? Plus minus. Yeah. All right, so I got plus 9 to both sides. Always got to watch the BS, make sure it's working out. And there we go. Questions? Chase, you got a question?
No.
Okay. All right. That is what we're doing today. Tomorrow we're going to do the quadratic formula, and then we're going to finish off with a couple more problems. Okay? So, homework time.